2 from section 3. We're going to use the polynomial identities. So Pedro is claiming that if he takes two positive integers, say 3 and 4, and letting those be x and y, as long as x is greater than y. So if these are my integers, this would be x and this would be y. So he says you can take two integers as long as one's bigger than the other, and they will fit this scenario. So if I have a right triangle, I could put one side as 2xy and another side as x squared minus y squared, and my hypotenuse would be x squared plus y squared. And that would fit for any right triangle is what Pedro's claiming. So we know one thing about a right triangle, maybe the one thing that you always remember, is Pythagorean theorem, a squared plus b squared equals c squared. Right, so as long as I have three sides, I can test it by plugging these in, right? I could put in 3 and 4 and see if that works, right? And I would get 5 for my c squared. So let's test these in Pythagorean theorem. So let's plug that into our a, plug that into our b, and plug this into our c, and see if it's true, right? So our a squared is pretty easy. That'd be just 2xy squared, which is just a 4x squared y squared. Then when I square this one, right, my b squared, that would be x squared minus y squared. And when I square that, that's actually taking a number times itself, right? So let me do some scratch work right here. That'd be x squared minus y squared times x squared minus y squared, which is x to the 4th minus y squared x squared, or you could switch those, and then timesing these together, which is another minus y squared x squared, and then these two together would be plus y to the 4th. Okay, so that's that one. So that would be x to the 4th minus 2y squared x squared, and then plus y to the 4th. Y to the 4th. And we're saying that equals c squared, which is x squared plus y squared, which is almost the same thing as this except for the minus, right? So then this would be the only difference. That would be a plus. So this equals x to the 4th plus 2y squared x squared plus y to the 4th. And are these two statements true? Okay, they both have y to the 4th. They both have x to the 4th, right? But then we have this minus y2, x2. Those are the same, right? So combining those two, wouldn't that be a 2y squared x squared? And isn't that what we have over here? Y squared x squared. So yeah, it is a true statement. So Pedro is correct. So there's another way that you could use, instead of Pythagorean theorem, you could use this. You could say, use this formula, that 2xy, and the other side would be x squared minus y squared. Then you know your hypotenuse would have to be x squared plus y squared.